Welcome. Good morning. I'm Richard Smith, a visual designer at Google.
I'm Alon Hetzroni, a UX engineer.
I'm Tianlu, Tang, an interaction designer.
We're part of the Android XR design team, and today we'll be talking about best practices for how to design wired XR apps. We'll also give a quick overview of Android XR, how it works, and what you can do with it. Okay, so why are we here? With the release of the Android XR SDK Developer Preview 3, we are expanding support beyond XR headsets to new categories of devices, XR glasses and AI glasses. In October, we launched Galaxy XR in partnership with Samsung, the first XR headset powered by Android XR. And coming next year, Project Aura will be released in partnership with XReal. This device will be a new pair of wired XR glasses. Before we get too deep into how to design for wired XR glasses, let's take a look at the current state of Android XR. Gemini helps bring Android XR to life. No matter where a user is, Gemini is always just a tap away. Gemini can see and hear the user's entire view, with permission, of course, giving it the power to give contextual responses, assist with tasks, and even help navigate the system. With Google Photos, users can browse their memories without the limitation of screen edges. Users can spatialize 2D photos or videos that they've taken in the past on any camera and view them immersively in a stereoscopic experience, just like they were there again. With Google Maps, users can search and discover points of interest throughout the world. Immersive View in XR opens up a new dimension in map exploration. Soar high above skylines, dive into neighborhoods, and even go inside to feel like you're there. With YouTube, users can fully immerse themselves in YouTube's entire library of content, including an ever-expanding catalog of 180 and 360 immersive video. Any Android-compatible app works on Android XR without any additional effort. But many developers are already making truly optimized experiences. The team at Adobe developed a new immersive video editing app called Project Pulsar. The app is a powerful and intuitive way to edit cinematic videos. Users can add real depth to their videos, as well as layer captions, icons, and other graphics inside of their 3D content, all on a larger-than-life display. With Demio, you become the star of an epic, immersive multiplayer game. And with the power of pass-through, the action comes to life right in the middle of your living room. We are incredibly proud of where Android XR is today, but we're even more excited about what's next. Like I mentioned at the top, Android XR is expanding to support a new category of device, wired XR glasses. These devices look a lot like a normal pair of glasses, but they deliver the full Android XR experience. When wearing a pair of XR glasses, users have a real view of the real world. They're not looking at video pass-through. They're just looking through glass. Wired XR glasses are smaller and lighter than traditional headsets. This allows users to wear them for longer and be much more mobile. And because users are actually seeing the real world, they're more connected to the real world. They can hold conversations with those around them, watch videos while they fold laundry, and even use the display as an extension of their laptop. And the best part is, for the vast majority of apps, no additional work is needed from you. Feel free to clap at any time, for what it's worth. Most mobile, tablet, and XR headset apps just work on wired XR glasses. But with some simple guidance, you can create an optimized XR glasses experience. Okay, let's do a quick refresher on how the Android XR system works. The primary way to interact with Android XR is naturally, with your hands. Just point with your hands, pinch, swipe, zoom, release, easy. But that's not the only way. Users can also connect their favorite Bluetooth mouse and keyboard. In fact, Android XR supports a variety of input modalities. The best part, the system abstracts this complexity for you so you can focus on designing a great app experience. Of course, every device will be unique, so it's important to check at runtime if your app depends on functionality that's specific to one kind of input, like 6-off controllers or eye tracking. This enables you to work around the differences in devices and provide the best possible experience to your users. On Android XR, a user can experience your app in 2 spaces, home space and full space. In home space, your app coexists alongside other apps. Most Android apps, especially those optimized for larger screens, can thrive in this space without any additional development effort. In full space, your app takes center stage while other apps are minimized. This allows you to fully utilize the capabilities of Android XR, incorporating elements such as spatial panels, 3D content, and customized environments. Users will open your app via the launcher, and depending on your experience, it can either open in home space or directly into full space. Users get around with the help of the gesture navigation. This allows users to open the launcher, use the back button, and access recent apps, a pattern that will be familiar to Android users. Once an app is opened, users have the ability to resize it and make it the perfect size just for them. With the same affordance, users have the freedom to move and arrange their digital content in a way that feels natural and intuitive. Android XR is designed to automatically adjust the UI size based on how far it is from a user. This ensures UI elements are easy to interact with, no matter how near or far an app is positioned. Now that you know how the system works, I'll hand it over to Tianlu to get into why we're all here. Specific recommendations for how to design for wired XR glasses.
Thank you, Richard. The good news is most apps won't need much adjustment to work on wired XR glasses. But by keeping a few things in mind, you will be able to create incredible experiences that are truly optimized for this form factor. First, let's talk about the display. XR glasses have a fundamentally different display than headsets. Specifically, XR glasses have an additive, transparent display. What does this mean? The display can only add light and cannot render black. The more black there is in a color, the more transparent it is. The only true opaque color will be pure white. Practically speaking, your app likely will appear more transparent compared to how it appears on headsets, phone, or tablet. Because of this, we recommend against using pure black as surface color. In this example, you can see how much legibility improves by simply shifting the backplane from pure black to a dark gray. For best result, we recommend using material color tokens for surface color. So you might wonder, should I never use black? In fact, using black is a powerful tool when creating an XR glasses app. In this example, black is being used to create shadows to convey a stronger sense of hierarchy and depth. Just like other devices, XR glasses supports both light and dark mode. Though, we recommend defaulting your app to dark mode. Dark mode draws focus to the content of your app, significantly increases battery life, and helps your experience feel more integrated into the real world. To ensure legibility, XR glasses add a layer of dimming between the physical world and all digital content. This is a physical layer of darkening on the lenses themselves. In practice, it feels like you are wearing a pair of sunglasses. The amount of dimming is adjustable by user. There's always a minimum amount of dimming that ensures content will have some amount of contrast against very light environments. And when dimming is turned all the way up, it almost entirely darkens the real world, allowing for full immersive experience with rich saturated color. Project Aura will support at least 3 dimming levels that user can control via a physical button on the hardware and through the quick setting menu. That covers the basis of additive display. Next up is field of view. In general, wired XR glasses have a smaller FOV than headsets. The FOV of Project Aura is 70 degrees compared to roughly 110 degrees for headsets. While expensive UI can be partially rendered outside of the FOV on glasses, the amount of content a user can see at a glance is not significantly less, since the extra FOV on headset is mostly peripheral. To accommodate various FOVs, Android XR offers default scaling, so most apps fit automatically. You can inherit this behavior or override it if you want more control, just to be sure to test your app in the emulator. The same adaptive design you've used on other form factors like phones and tablets can be used on XR glasses. This is a great way to reuse your app's existing adaptive logic to accommodate a range of XR devices' FOVs. To blur the line between physical and digital, the edges of FOV on XR glasses are softly feathered. This creates a much more comfortable and natural experience. The system will do this automatically, so no need to do anything extra on your part. Last but not least, UI placement should be carefully considered in relation to FOV. Place important UI in the center of FOV and at a comfortable distance. And consider a safe zone, so key content doesn't clip as users slightly move their head or due to variations in fit. Though it is okay if peripheral information bleeds outside of the safe zone. That's a great segue into mobility considerations. XR glasses differ from headsets by overlaying digital content onto real world, rather than replacing your view with a video feed. They also tend to be smaller and lighter. Because of this, users wearing XR glasses are more likely to move around their space and multitasking with the real world. For instance, you can continue enjoying the game while answering the door or following the recipe while making dumplings. Implementing UI following behavior can be helpful when designing for greater mobility. For non-interactive elements, consider using tight following to keep them locked to user's view. For ephemeral UI such as notifications, consider using teleport following, which resets the UI position when out of the view. And for more persistent UI such as media, use soft following that allows the window to gently track users' movement. When designing for stationary users, consider using word-anchored content that further blurs the line between the physical and the digital. To achieve this, we recommend allowing users to anchor UI elements to physical space or object by leveraging technologies such as plane detection, spatial anchors, and object recognition. As we mentioned earlier, the display of XR glasses have a physical layer of dimming. If the dimming is set to the max, the world will fade to nearly black and your content will take center stage, which is great for stationary experience that either fully immersive or require greater user focus. Okay, now I'm going to pass it along to talk about using familiar patterns.
Thank you, Tianlu. An XR Glasses app should feel like a natural extension of your experience on any other platform. A user should just know how to interact with it. When designing your spatial Android app, you don't have to start from scratch. You can follow familiar Android patterns and foundational principles. Android XR is designed to adapt mobile and large screen layouts and automatically scale UI elements for optimal interaction in XR. While apps developed for large screen adapt best, you can easily bring any compatible Android app to wired XR glasses. Our platform leverages established best practices and patterns for material design and Android for large screens. In home space, Android XR will automatically scale your experience to make sure hit targets are easy to interact with. While existing material design guidelines translate to XR, we recommend a 56 dp target or higher. Additionally, unlike on mobile and tablet, it's important to have clear hover and press states so users are confident in their selections. Familiar patterns can also be taken from existing XR interaction paradigms, where you can design 3D interactions from real world. Video games have been exploring spatial interactions and are a potential source for novel patterns that can feel both native and familiar. Finally, spatialize with purpose. Spatializing interfaces can be done in many different ways. The key is to make sure you're always doing it intentionally. One great way to spatialize is by using focus to reveal and hide extra information, allowing your app's content to take center stage. In this example, the navigation is triggered when the user looks up. Utilizing depth is a powerful and unique capability of XR. When used with purpose, it can dramatically improve hierarchy of your app and bring clarity and joy for your users. And don't be afraid to break out of traditional confines of app panels. In XR, there's no need for boundaries. Not all spatialization has to be dramatic, though. Subtle depth cues, together with motion design, can elevate an experience, communicating hierarchy, emphasizing content, and guiding the user's attention in a way that feels native in three-dimensional space. And finally, sound is a powerful tool to enhance immersion and heighten emotional impact. Consider adding spatial background sound effects with ambisonics to create a rich atmosphere. Spatial audio is also helpful to draw attention to important UI and help users feel grounded in the mixed reality. That was a lot. Let's take one more look at some of the highlights. Most importantly, Android XR now supports a wide variety of devices: XR headsets, XR glasses, and AI glasses. Of these devices, wired XR glasses are most similar to XR headsets, but it's important to recognize the differences. XR glasses have an additive display that doesn't render black. They have a wide FOV that's slightly smaller than an XR headset. They ground users in reality through a see-through display, and they allow users to be more mobile. From a system perspective, Android XR supports multimodal input, two main app modes, home space and full space, and allow users to be in control of the size and placements of apps. And finally, although any Android-compatible app will just work on wired XR glasses, with some adjustments, your apps can really shine. Consider adjusting the surface colors of your apps to work well on an additive display. Designed for a range of FOVs, consider your app's scale and layout and how they will be perceived by users. Make sure your app takes into account how a user will be interacting with it, either on the go, blended with reality, or fully immersed. Start with familiar patterns. Make it easy for a user to know how to use your app. Spatialize your experience, but always do it with purpose and intention. And with that, you should be creating a great XR Glasses app in no time. That's it. Easy. Thank you for attending our talk. For a deeper understanding, please visit developer.additive.com. wired.android.com. We hope you're as excited about wired XR glasses as we are.